Example 3. Rewrite radical functions to identify transformations. How can you rewrite the following radical functions to identify the transformations from the parent graph of f of x is equal to root x? So this is our parent function, and from f of x, we're going to identify the transformations. So for the root functions, we also have transformations. And so we have looked at the form in the concept video last time, right? The radical function has this form where A is a vertical stretch or compression, H will determine horizontal translation, K is a vertical translation. So H and K will move our point to the end point, to where it's starting, where the graph is starting, especially for the square root function. So let's look at root 9x. For this one, A should be in our form we have right now. We're going to just look at the vertical stretch or compression. So we're going to change this form into a different form. So root 9x, we're going to separate this into root 9 times root x. And then we're going to simplify root 9 as 3. And so that would be 3 root x. And so 3 would be our A. So that means the graph has a vertical stretch by a factor of 3. So if you look at the same x here, for example, 9, 3 is our original point in our parent function. And then we see that the value 3 has multiplied to 9. So this really, your graph has stretched vertically. And so we're not going to look at horizontal stretch or compression because then it would be too complicated. Or we want to unify the transformation that we're using for stretch and compression, because it will be the opposite for horizontal, but we want to make everything in the same form. Okay, so we're just going to use the value A for vertical stretch or compression, and then H and K is just 0, so it didn't translate. The graph didn't translate. Let's look at part B. What about H of x equals root 4x plus 16 and then plus 7? So if you look at the form here, we don't have A, but we can factor out and change this form to figure out what A is, because we want 1x minus h, okay, for the radicand. So we're going to factor 4 out because that's the greatest common factor, and that's 4. And then we're going to rewrite this into root 4 times root x plus 4. And then root 4 is really 2. So then we have 2 times root x plus 4 and then plus 7. So now we have this form. A is 2, and then h is negative 4, and then k is positive 7. So we know that it vertically stretched by factor of 2, and then it translated, this graph translated 4 units to the left, 7 units up. So this is our new graph. Okay, let's look at try number 3. What transformations of the parent graph of f of x is equal to root x produce the graphs of the following functions? So with the same parent function root x, square root of x, we're going to describe the transformations for parts A and B. So pause the video, see if you can figure it out by yourself for practice, and come back when you're ready for answers. Okay, are you ready? Let's look at part A. M of x is root 7x minus 3.5 and then minus 10. So we're going to change this form, right? You're going to factor out 7, the greatest common factor, and have x minus, that's really 0.3.5 divided by 7 would be 2, so 0.5, right? And then minus 10. So this is root 7 times root x minus 0.5, and then minus 10. And so our a is already root 7. You don't have to make this into a whole number. If it's root 7, then it's just root 7. So a is root 7, h is 0.5, positive 0.5, k is negative 10. Using these parameters, we're going to describe our transformations of the function m of x. So m of x is a vertical stretch of root 7 and a translation, half unit to the right and 10 units down of f of x. So that would be our first answer for part A. Let's look at part B. This is not in the form of a root x minus h and then plus k, right? So we're going to separate the radicand, factor it out. So negative 2, root 12 really is root 2 times 3, right? So then this is really root 2 squared times root 3, and so this is really 2 root 3. So this is really 2 root 3 and then root x, right? And then you can simplify the constant. That's going to be root 4 root 3, and then you have root x, and I don't want to combine the roots, right? Because that's just gonna be a, and your a could be in different forms. As long as it's real number, that's fine. So a is negative 4 root 3, right? And then we have h is 0, k is positive 4, and so using this you can describe let me type. You can describe j of x. J of x is a reflection across the x-axis because a is negative, is compressed by a factor of 4 square root 3, and is a vertical translation 4 units up. So see if you got these right, and if you did, good job. That was example 3, and try number 3. Let's look at example 4. Write an equation of a transformation. What radical function is represented in the graph? Compare the graph to the parent graph of cube root x. So now we're going to look at the parent graph of cube root x. We have 0, 0, 1, 2, 1, 1, right? If it's a parent function. So this one would have 1, 1, and we have a, 2, and so on. Negative a, negative 2, and so on, right? So this function, we're trying to figure out the equation for that. And we definitely see a vertical stretch, right? From here to here, your point is stretched. Your point is stretched vertically, and so you're going to have a. This is not reflected, so this is just going to be a positive a. Your h is 0, k is 0. So as long as your middle point right here, the inflection point doesn't move and it's at 0, 0, your graph will have h is 0 and k is 0. So this graph is going to have a reflection and a vertical stretch. Wait, no reflection and a vertical stretch. So you're going to you're going to figure that out by using your function. So using these points, you can figure out a. When g of x, let's say g of x is equal to a times cube root of x minus 0 plus 0, right? And then we know that one of the point is 1, 2. We know 2 is equal to a times root 1. And root 1 is 1. So a is just 2, right? So then your g of x equation is just 2 cube root of x. Okay, so the function g can be written as g of x is equal to 2 cube root of x, or you can put 2 into the root by multiplying 2, like cubing the 2, and then doing writing in a different form. All right, so let's look at try number 4, radical function. Which radical function is represented in the graph below? Looking at the graph and the points given, you can write the equation for the function. So pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? Let's look at part A. So we have the starting point at -5, -4. We know that the graph from the original parent function shifted from 0 to -5, -4. So we know that this is h and that's going to be k because h represents your x value and it's a horizontal translation, right? And k represents your y value here represents the vertical movement, and that's your k. And so we're going to use the function, let's say g of x is equal to a. We know this is a square root function because it has an endpoint and one arrow, right? X minus h plus k, and so that's going to, yeah, and that h is going to be -5, and so it's x plus 5, and then you have -4, and then using one of our points, you can use -1, -2. You can plug it in and solve for a root -1 plus 5 minus 4, and then that's equal to 5 minus 1 is 4, and so that's 2. 4 minus 2 is 2, so 2 divided by 2 is 1, right? So we know that a is just going to be 1. And so our real final equation would be g of x is equal to 1 times root x plus 5 minus 4. They just translated, no stretch. Let's look at part B. We know this is an odd function because we have 2 arrows, and yeah, and we have a middle point here, right? So that's gonna be our h comma k for the cube root function. So let's use a different function notation. H of x is equal to a cube root of x minus h plus k. It's just the index that's going to be different, but the form itself is the same for all radical functions, okay? And then you know h is 0, k is -2. So rewrite that. A cube root x minus 2. And then use another point. Don't use the h and k. Let's say 2, 0, right? 0 is equal to a root cube root of 2 minus 2. And then, yeah, and then that means we have 2 is equal to a cube root of 2, and then a is equal to 2 divided by cube root of 2, and in order to rationalize your denominator, you want to multiply cube root of 2 square, right? And then get 2 in the denominator, and then you have this 2 is really cube root of 2 cube. So yeah, so you have yeah, you have 2 cube root of 2 square, but then that's canceled out. So really you have cube root of 2 square, which is cube root of 4. So a is cube root of 4, so your equation is going to be cube root of 4x minus 2. Yeah, and you can just put it in there as well. Yeah, since your h is 0, you can just combine the root together to simplify. All right, so that was try number 4, A and B. Check your answers, see if you got it right. If you did, good job. Let's look at the last example, example 5. It's the application word problem. Interpret a radical function model. So now that we have learned the radical function, and how to write equations given some information, we're going to look how it's going to be represented in real life. Looking out into the sea, the visibility in miles from a certain spot on a cliff can be calculated using the function d of x is equal to root 1.5x, where x is the height and feet above sea level. Sasha walks through elevations ranging from 5 feet to 40 feet above sea level. What are the minimum and maximum distances that she can see? So you're going to use this function, right? X represents the height above sea level, and then d of x, the range, represents the visibility from her area, right? And so we want to find the minimum and maximum distances that she can see from 5 feet to 40 feet. And how can we figure that out? Well, first, it'll be helpful if we graph this function, and then we can see if there are any minimum or maximum points, right? So from the graph, you'll be able to see the minimum and maximum points. So step 1, graph the function, look for minimum and maximum. We have a minimum and maximum at the endpoints. So we know from 5 feet to 40 feet, that's going to be our visibility range, right? But at 5 feet and at 40 feet, we have a minimum and a maximum. So we just have to calculate the actual distances in miles using the x values, which is the height in feet of the endpoints 5 and 40, right? So all the information that they provided us are very important. So using 5, you just plug it into the equation. Using 40, plug it into the equation and see what the values are for the function. And if you get the value for 5 feet, that's just going to be your minimum, and 40 feet would be the maximum, right? So d of 5 is about 2.74, and that's going to be our minimum. And d of 40 is about 7.75. That's going to be our maximum, right? So then the minimum and maximum distances, as you can see, are approximately 2.74 miles and 7.75 miles. Let's look at try number 5. Use the same function as in example 5. Suppose Sasha's brother walks through elevations ranging from 8 feet to 48 feet. What are the minimum and maximum distances that he can see? So pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? All right, let's look at the equation. You're using the same equation, right? So it's going to be d of x is equal to root 1.5x. That's what they give you initially. You're using the same equation. And Sasha's brother is now walking through elevations ranging from 8 feet to 48 feet. So we want to find the minimum and maximum distances. So using the same graph, 8 feet is about here, right? And then 48 feet would be here. And the graph is still going to increase, right, throughout your interval. So you know the minimum value would be 8. And then maximum value would be at x equals 48. So you just have to calculate them. D of 8 is root 1.5 times 8, and that's root 12. and that's about 3.4641. And then d of 48 would be root 1.5 times 48, which is root 72, and that's about 8.48528. Yeah, and so that's our answers. Let's see. So approximately 3.46 miles and 8.49 miles would be our answer. All right, so that was example 5 and try number 5. Let's look at the concept summary and summarize our lesson. Use transformations to graph radical functions. We can understand how the values of radical function transform the graph of the parent function. So from the parent function, we have the parameters a, h, and k that will vertically stretch or compress, or horizontally translate or vertically translate your graph of the parent function. So these are some examples of the even degree radicals and the odd degree radicals. And this is a parent square root function f. And then, for example, you have 2 root x plus 1 minus 3. And a is the vertical stretch by 2. And then you move 1 to the right because h is negative 1. And then k is negative 3, so you go down. And then here, that's your parent function, and it starts with 0, 0 for your inflection point, right, the middle point. And then you go up and right, so that means you have h and k, and then it seems like the graph is compressed vertically just by looking at it, right? If you have specific points, you'll be able to figure out the equation, the specific equation as well. So those are the things that we looked at in this lesson. And so that was 5-3, transformations to graph radical functions. We'll continue with the next lesson in the next video. Thanks for watching.